Let's move on to a couple of examples in this section called disaster risk reduction. We'll look at Bangladesh and then move on to another example of coastal regions. So framework, stories and learnings from disaster management in Bangladesh. Key messages Bangladesh has. Framing is basically where you take a problem and you place it in a context. It's called literally framing, like a picture. Stories are good for narrating experiences and lessons learned, etc. So that's where the learnings from disaster management come from. Bangladesh has developed a robust framework for disaster management institutions, plans and rules to deal with climate vulnerability over 3 decades. Remarkably good progress for a country that's not so rich and lies basically at sea level and is highly vulnerable to climate change. The framework includes vertical integration of institutions across various levels of government and horizontal integration of stakeholders within each level. So people in the each level are integrated in terms of information and shared activities or shared actions when there is a disaster. Participatory processes and community engagement at the grassroots level have emerged as successful examples of efficient and cost-effective solutions that leveraged traditional knowledge and reduced loss of lives and livelihoods. So it's kind of a nice example of how without all the IPCC humdrum, people can use traditional knowledge to accomplish a lot of these things. There are many such examples of indigenous people protecting fisheries, protecting forests, protecting sacred lands, and so on and so forth. Deaths due to floods and storms by decade in Bangladesh since 1970. So here are the floods, here are the total number of deaths, and you can see a remarkable drop from almost 30,000 here down to basically about 5,000 or so. Total impacted number also is down. It peaked here in the 80s and 90s, oh sorry, 80 to 90, and then went back up compared to the previous period. And the population demographic changes are of course part of this story as well, so you have to be careful. In terms of storms, again you can see a remarkable drop in number of deaths and number of people affected as well. So Bangladesh is in a kind of a unique situation because there are small islands inhabited by people doing fisheries and whatever else. So even if a cyclone is coming, large-scale evacuation is not very easy. So it's remarkable that despite these sorts of limitations in the geography and the distribution of people and habitats, they are able to reduce the number of deaths from storms as well. Okay, so here is a schematic showing educational material showing Rana Bhai talking about climate change. So I won't read all this. This is in Bengali material here. So this is climate change, and this is how stories and narratives are developed, and he's asking what should we do. And so you can see this guy is giving some knowledge, basically grassroots level efforts based on traditional knowledge used to actually deal with climate change impacts. Just to read concluding remarks, disaster management and emergency response will be part of the new reality as the world experiences a rapidly changing climate with uncertainties and inadequate global response to reverse the course of human activities that fueled this crisis. We've talked about before that countries like Bangladesh haven't really contributed much to the historic emissions that led to climate change, but they are now paying the price in terms of being the most vulnerable. So the rich world is not mitigating their emissions fast enough to reverse these effects. Unexpected events such as the COVID-19 pandemic will further endanger communities, exacerbate vulnerabilities, and alter the traditional ways of life. We hope that the detailed description of the institutional mechanisms, perspectives on implementation of the programs at the ground level, and stories of innovation from Bangladesh presented here, which I didn't read all of it obviously, that these will offer useful lessons on disaster management for other South Asian countries, developing nations around the world, and vulnerable communities of Western countries. So even in rich country like the US, there are people who are highly vulnerable basically because of their socioeconomic status. There are relations to race and color and so on that we won't get into. As for Bangladesh, while the country has managed to significantly reduce human casualty, many more are likely to succumb to future disasters. There is a long road ahead with opportunities for further innovation, but no room for complacency. So we'll move on and look at another one, valuing the role of mangroves in storm damage reductions in the coastal areas of Odisha, which is again eastern coastal state from India, very well known for getting hit by cyclones repeatedly, and it has done remarkably well in responding to early warnings from the governments, which have gotten better on saving lives. Storm protection service of mangroves is very high for cyclone prone regions. Mangroves provide a natural barrier against storm surge and storms themselves, and they also filter the nutrients going from land into the ocean, and they improve the habitats, oxygen for many of the species that live there. Livelihoods depend on mangrove forests and so on as well. During 1999 super cyclone in Odisha, which is a poster child for a massive disaster in India, every hectare of mangroves provided storm protection in the range of US dollars 4335 to US dollars 43,352 to the Kendrapada district, which is 25 to 249 times the 99 per capita income of the district, which was at US dollar 174. You have to read the book chapter to see how these estimates were made, but ecosystem services such as these are always kind of debated. People don't necessarily pay for it, but once you are saved by them from, let's say, a cyclone, you can retroactively put value on them. But if you ask people to pay for it to preserve them, then you don't necessarily get people to pay up. The annualized storm protection value of mangrove hectare is more than 2 times the land price of cleared forests and more than 20 times the annual return from alternative land uses, clearly justifying mangrove conservation to receive storm protection. Again, these are good intrinsic values. How to actually get people to realize them and value them and protect these is not always clear. Using climate information for building smallholder resilience in India. Again, the main messages: user-specific, relevant seasonal climate forecast forecast information has the potential to induce risk-reducing decisions for players across the agricultural value chain. We have discussed this a little bit in other contexts as well. The lead time and forecast requirement for seasonal climate forecasts are diverse across the value chain and might induce competitive complementary decisions across the value chain. SCF needs to be bundled with institutional support for better uptake and competitive advantage to the smallholder farmers. So this information is a bit dated in the sense now the short-term, medium-term, extended range so-called subseasonal to seasonal forecasts are being effectively used to guide many of the agricultural decisions. Obviously they have to get much better, much more granular in space and time, but nonetheless seasonal outlook fora in Asia and Africa, in even South America, served the communities very well in the 80s and 90s, but since the last couple of decades we have moved also to the so-called S2S forecasting systems. Okay, reading few of the decisions. Key on-farm decisions and influence of climate information. Key decisions include time of sowing, choosing of crops, crop variety, irrigation management, timing of irrigation and quantity of water to be applied, resource use allocation, labor and finance, fertilizer application, quantity, type and stage of application, timing of pesticide application, time of harvest, etc. Key climate variable that informs the decisions: onset of monsoon, total rainfall and its intraseasonal distribution, total rainfall and its intraseasonal distribution also for irrigation management. Total rainfall and its interseasonal distribution also helps resource use allocation like labor and finance. Distribution of rainfall across crop growth stages for fertilizer application, wind direction and speed, rainfall distribution across crop stages for timing of pesticide application, time of harvest needs information on distribution of rainfall during crop maturation stages. If there is heavy rainfall at the wrong time, you get massive crop damages, which is pretty well known. Forecast and lead time requirements expressed by farmers. Forecast requirement, number of farmers articulating here. I won't read these numbers, but you can see here what the forecast requirements are according to farmers. Total rain for the season, onset of rain for the season, distribution of rain, interseasonal, lead time in months, days before sowing, 1, 2, 3 or 3 to 4 days before sowing, and so on. So total may not add up to 242, as these are multiple responses in terms of the total number of farmers surveyed here. Okay. Let's read one more. Farmer adaptation to climate variability and soil erosion in Samanala Veva catchment in Sri Lanka. Mean annual rainfall has decreased while mean annual temperature has increased from 1922 to 2008. That's a very long time series. It's also observed that the general perception of the farmers is also similar in terms of the overall trend. So they have experienced these and they have records going back that far, and Sri Lanka recently had serious issues because of COVID. Tourism dropped off, which is the Sri Lanka's main income, and they had switched to organic farming on a large scale based on a whim, literally. Good idea, but bad implementation, and that added to the woes when the incomes dropped and there were all kinds of political instabilities, and they are still recovering based on the loans they got from various countries and agencies and so on. Let's read this before we move on to the next section. Climate resiliency and location specific learnings from coastal Bangladesh. Key messages: from the perspectives of coastal areas of Bangladesh, location-specific learning effects have a strong connection with socially heterogeneous coastal populations' climate resiliency efforts in terms of their gradual investments toward storm-resistant homes. This Bangladesh is really vulnerable to storms, and as we said, it's mostly a river delta with lots of small islands literally at sea level, so storm surge is a big concern for them, especially with sea levels rising. The northern Bay of Bengal is a hotspot for sea level rise because massive amounts of sediments that come from the Himalayan rivers that originate in the Himalayas are pressing the land down and raising the sea level. There is an acceleration of sea level that's one of the fastest in some corners of the Bay of Bengal next to Bangladesh. Location-specific learning effects are more evident among the socially heterogeneous coastal households that are located close to government-sponsored embankment and cyclone shelters, nearest vehicular road, primary school, and the natural capital such as the mangrove forest. So all these lessons have to be documented like it is done in these chapters, and then the knowledge can be shared and applied elsewhere as appropriate. Okay, we will read on urban sustainability from this book, but then I have a separate section on urban resilience from a couple of other books that I'll summarize in the next chapter. I'm just calling these chapters in the course podcasts, but obviously they are sections from different books. I just arranged them as chapters, which is good enough, right? So we'll leave this here for now and maybe come back and wrap it up in the next podcast. Okay.